Alright, we have notes, alpha number 2, operations with functions. The nice thing about these operations is it is what you would expect it to be. They are intuitive, sum. If it says f plus g of x, it simply means f of x plus g of x. If it says f minus g of x, simply means f of x minus g of x. Exactly what you would expect. F times g of x equals f of x times g of x. Please note this is a multiplication symbol. It's a darkened in dot as opposed to an open circle, not darkened in. That means something different. Then the quotient, which is what a fraction is, a quotient, f divided by g of x is the same as f of x divided by g of x, as long as g of x doesn't equal 0. And the reason that this says this here doesn't say it anyplace else. Recall that if g of x does equal 0, then that would give you undefined, because you can't divide it by 0. It's an undefined thing when you divide by 0. So that's it for the notes, just examples after that. Well, at least for the rest of this page, just examples. Given that f of x equals x divided by x plus 3, and g of x is x squared minus 2x, find each function below. Please note the note. If it applies, find the excluded values. Recall that excluded values can be found if you have a fraction and a variable is on the bottom of that fraction. Can also be found if you have an even root radical and there's a variable inside of it. You can find the excluded values at any point in the problem. You just have to remember to do it. So I'll probably stop at some point and tell you the best time to do it. Each problem is different. First of all, f divided by g of x means f of x divided by g of x. I'd like you to write that down. Then substitute for f and for g. F of x is x divided by x plus 3. G of x is x squared minus 2x. Quick recap on what a grouping symbol is. Grouping symbols can be parentheses, brackets, can also be division. A division bar is a grouping symbol. So that means that the entire top is one group, the entire bottom is one group. The reason that I'm pointing this out, when you substitute, and you're substituting for an entire numerator or denominator, you do not need these parentheses. If you're substituting for part of the numerator or part of the denominator, then you should have the parentheses. We're not doing that. If you want to put them there, you can. It doesn't hurt anything, but it is unneeded. So we're supposed to find the function. Well, this is not simplified. It's not simplified. The main reason we have a fraction within a fraction, which is something that we don't want. So to fix this, it's rather simple. We take our numerator, we write it down, and instead of dividing, the symbol here means division, instead of dividing, you can multiply by its inverse. So that's the same thing as times 1 over x squared minus 2x. Just a quick recap from 4th grade, 5th grade, I don't know. If you had 3 over 2 divided by 7, for example, you would say, well, let's make that 3 over 2 times 1 over 7. You would reciprocate what you're dividing by. And you would change the division to multiplication. It's the same thing that we did here. We changed the division to multiplication. We took what we were dividing by, we reciprocated it. At this point, before you actually multiply these things out, what you're probably going to want to do, and this is preventative measures basically, you're going to probably want to factor each part of this problem. Factor this numerator, this numerator, this denominator, this denominator. Sometimes you'll factor it and it ends up being pointless. Sometimes you'll factor it and it won't be pointless. So let's factor this. This numerator, x, is already factored. This 1 is already factored. X times 1 is x. X plus 3 is already factored. I'm going to put that in parentheses because I'm multiplying that by this denominator. This denominator here has a GCF of x, so I can factor that out, leaving me with x minus 2. So this particular problem, it was important to factor. And the reason is we can now cancel an x from the top and the bottom. When I say cancel, what that means in this context, you're multiplying the top of the fraction by an x. This is an x times a 1. You're multiplying the bottom by an x. We have an x times these things. If you're multiplying the top and bottom by the same thing, then you are allowed to divide the top and bottom by that x, and they cancel each other out. Before you cancel, it's important to find excluded values before canceling anything. So I'm going to take this denominator, I'm going to write it down here, and I'm going to say, guess what? X cannot be these things. Take my whole denominator and I set it equal to, I'm sorry, I did that incorrectly. I'm saying those things cannot equal 0. My denominator cannot equal 0. I rewrote the order of these terms for no particular reason. Since this is already factored, since we already did that factoring, that means that I can simply take each factor, set it equal to 0, and solve it. So I got 0 doesn't equal x plus 3. I got 0 doesn't equal x minus 2. And I got 0 doesn't equal x. If I solve each of these, I'm going to get x can't be negative 3, x can't be 2, and x can't be 0. So all this, once again, was excluded values. Continuing with this problem, that's just a side step there. And once again, you do that side step once you have simplified as best you could without canceling things. In other words, you've factored, you've made it one fraction instead of multiple fractions. Could have done it before that. This is where I typically do it. You could do it at the beginning. That would work as well. Because we have this denominator here and this denominator here. Alright, continuing, we can cancel an x out of the numerator and denominator because you're dividing something by itself. That means there's a 1 left in the numerator. If you cancel with division, there's a 1 left. So we have a 1 in our numerator. Our denominator, we have x plus 3 times x minus 2. Simplifying this, we need to make sure that we don't have any parentheses when we're finished. So if you FOIL the denominator, you're going to get x squared minus x, plus x minus 6. Now the reason that is that way, here's something, this is optional work. I do not need to see this. Everything else I'm hearing I need to see. Using the FOIL or box method. Multiply x times x and I get x squared. I multiply x times negative 2 and I get negative 2x. 3 times x is 3x. 3 times subtract 2 is subtract 6. Combine like terms and I get this. This, once again, is all optional. So what is my answer? To write your answer, you write down the question. F divided by g of x equals, write down the simplified version. Do not forget, you put a comma, you say what x cannot be, the excluded values. We found those excluded values down yonder. X can't be -3, can't be 2, and it can't be 0. So we simply say x can't be -3, 0, and 2. That makes this here our answer for number 1. That's division. Going down to number 2, this is addition. Addition is the easiest, I think. No, that's not true. Addition is not the easiest. Multiplication is the easiest. Addition is one of the more difficult ones. What does f plus g of x mean? Well, it means f of x plus g of x. Yes, you do have to show this step. Well, I shouldn't say you have to. You're an American. You don't have to, but you're going to lose a point every time you don't do it. What is f of x? Well, that's x divided by x plus 3. What is g of x? That is x squared minus 2x. It's important here. I'm substituting that I use parentheses. You don't need it for the fraction because it's understood that a fraction is one thing. It doesn't need it. You can if you want. The x squared minus 2x is 2 terms. You're substituting. It should be in parentheses. For addition, it really doesn't matter if you have parentheses or not. For subtraction, it does matter. So I suggest that you always do it, and you won't have problems. So continuing, we know we're going to have excluded values because we have a fraction. We don't find it yet because you might end up with more to your denominator at some point. Let's see what happens. Quick flashback to your younger years. How do you add 1/2 and 8? Well, you have to get common denominators. Change the 8 to 8 over 1. This denominator is 2, this is a 1. So we can take the fraction on the right and multiply the top and bottom by 2, which gives us 16 over 2. Once you have common denominators, you add the numerators and you get 17 over 2. So the point in me showing you that is just to refresh your memory of how to add 2 fractions because you probably haven't done it for quite some time. This denominator is x plus 3. This one is a 1. So I need to change this so it has an x plus 3 on the bottom. I can't just multiply that on the bottom. I have to also multiply it on the top. Now they're common denominators. Once you have common denominators, you add the numerators. Leave the denominator as just 1. Let me write that one time. So we're being close to being finished here. It's difficult to say if we could factor this until we first multiply this out, and then we'll see if we can factor it. So using the FOIL or box method, x squared times x is x cubed. X squared times 3 is positive 3x squared. Minus 2x times x is minus 2x squared. Minus 2x times 3 is minus 6x. My denominator hasn't changed. It's x plus 3. I have like term here and a like term here, so I can put those together. Typically, we like to put the terms in descending order with respect to the exponents. That means the biggest exponent first, and then followed by the next biggest, all the way down to an exponent of 0 if you have one. This is x cubed. Combining these two gray terms, we're going to get plus x squared, and then minus 6x, Oh, I got another pair of like terms here. Missed. X and a minus 6x. That's a minus 5x. I'm going to need to factor my numerator to see if I can cancel it with something from the bottom. Before I try to cancel things, I want to make sure that I find excluded values. So I take my denominator and I say the denominator cannot be 0, which then I'm saying x cannot be negative 3. This numerator here factors. GCF is x, gives me x squared plus x minus 5. See if this factors more. I'm looking for two things that multiply to give me negative 5. Same two numbers add to get me positive 1. You'll find that no such numbers exist. This does not factor anymore. Leaving it in this state, x times this polynomial, does that cancel with the x plus 3 on the bottom? It does not. Some people would say, well, you can cancel an x with an x. It's partially true. If this x was being multiplied, then you could cancel it. It's being added. If you're adding something, you cannot cancel it. So this doesn't factor enough to cancel anything. So if it doesn't factor enough to cancel anything, then if you already wrote that down, which I'm sure you did, just right beside it, it doesn't help, or something of that nature. So our final answer, f of x plus g of x equals x cubed plus x squared minus 5x divided by x plus 3, except x cannot be negative 3. This is our official answer to this problem. On the flip side, just figure out what f minus g of x is. This is a little more complicated. The work's pretty much the same, but there's just one thing you got to keep in mind. F minus g of x is f of x minus g of x. F of x is x over x plus 3. G of x is x squared minus 2x. So important for these parentheses here. You will get the wrong answer if you don't use parentheses. Need common denominators. So I'm going to multiply the bottom and top of this second function by x plus 3. This negative right now is a problem. There's several ways for me to fix it. I could have already fixed it. I'm just going to continue here and show you another way that I can fix it. Writing this as one fraction. When you're subtracting, you subtract the numerators, leave the bottoms the same. This next step is going to look a little different than number 2, besides the subtraction. When I multiply these terms, x times x squared times x, I get x cubed. Now it's important, since I'm subtracting everything that's happening after this, that I put brackets, parentheses around this something, because I have to change the signs of each of these things. X squared times 3 is plus 3x squared. Minus 2x times x is a minus 2x squared. Minus 2x plus 3 is a minus 6x. All over x plus 3. So once again, to get rid of this subtract symbol, I need to, in essence, distribute a -1 that I'm multiplying times each term, or change each plus to subtract, each subtract to plus. So this is going to become x minus x cubed minus 3x squared plus 2x squared plus 6x over x plus 3. Like terms, these x squared terms are like terms. These x terms are like terms. If I put those together, I'm going to get negative x cubed minus x squared plus 7x all over x plus 3. Does this numerator factor? I'm not going to erase this time. I'm going to leave this here. Does it factor? Well, I can factor a -1 out of the numerator. Reason I'm choosing, negative x. Reason I would choose a negative instead of a positive x, I prefer my lead coefficient to be positive. And does this factor? Can you multiply two things to get -7 and add to get +1? No, you can't. So this is as far as we can go with it. Can't forget excluded values. At no point in the problem did I cancel anything from the denominator. So I can just take the denominator that I have here at the end. X plus 3 cannot be 0. Therefore, x cannot be -3. If x were -3, we would have an undefined solution. So our answer, f minus g of x equals negative x cubed minus x squared plus 7x over x plus 3. Next part of the notes, composition of functions. Given functions f and g, the composition function f of g. This right here is an open dot, as opposed to multiplication, which is a closed dot. Can be described by the following equation. F of g of x equals, pardon my language here, but f of g of x. It means that you take g, that function, and put it into each x that's in f. Normally in this country, we read from left to right, top to bottom of a page. Typically in math, we go left to right, top to bottom. We still read it that way. But when you do the actual composition, you actually work from right to left. The domain of f of g includes all elements in x in the domain of g, in which g of x is in the domain of f. In other words, check your excluded values. Example B, find f of g of x. Well, once again, we're working from the right to the left. F of g of x means f of g of x. So here's what we're supposed to do. We're supposed to take g of x, which is x plus 7. We're supposed to go up here into function f, and every time that we see an x, this little guy right here, replace it with x plus 7. That's what we're doing. Color coding for your viewing pleasure. So we got function f. Instead of writing an x to the right of it, we write g of x. So what is g of x? It's x plus 7. So we're putting an x plus 7, replacing it with g of x. They are the same thing after all. moving from right to left. We're changing things from right to left. Now function f, we write that down. But every time we get to an x, we don't write x. Instead, we write x plus 7. To further emphasize this, I'm not going to even write that. I'm just going to put an open set of parentheses. So here we have f of x. It's 1/2 times something minus 5. In this blank spot, we're supposed to put an x plus 7. So essentially, all we did, took this function right here, replaced this x with x plus 7. That's what just happened. Distribute the 1/2, you get half of x, half of 7, 3.5. Combine like terms, 3.5 and minus 5 is a minus 1.5. Second part to this problem is do the opposite. Do g of f of x. So we get g of f of x. So for this problem, we are to take our function g, and instead of putting x's into the problem, put whatever this function says to put in it. So that's g of, what is f of x? Well, it's 1/2 x minus 5. We're replacing f of x with what it's equal to. According to this up here, f of x is equal to 1/2 x minus 5. So now it's saying take function g, which is x plus 7, replace the x with whatever f of x is. F of x is 1/2 x minus 5. So essentially, once again, what has happened here? G of f of x says take function g of x, and every time that you see an x, replace it with 1/2 x minus 5. That's all it says. Take 1/2 x minus 5 and put it right in there in place of that x. That gives us 1/2 x minus 5 plus 7. Combine like terms, because the parentheses here have no mathematical value, and we get the following. Almost forgot, excluded values. Any place in this problem above here, is there an even root radical or a denominator in which there's a variable? There is not. Therefore, there's no excluded values. Down yonder, no fractions with variables on the bottom, no even root radicals. So that's all we have to do for that. Alright, number 2. Same kind of problem. What is f of g of x? Well, it's f of g of x. What is g of x? It's x minus 2. So we take function f and replacing the x's with x minus 2. Order of operations, you do exponents first. We're going to get x squared minus 4x plus 4. Distribute the 3. We're going to get 3x squared minus 12x plus 12. G of f of x. Well, that means that you're going to put f of x in for all the x's in function g. F of x is 3x squared. So that is x minus 2, which is what g of x is, so it's 3x squared minus 2. There no like terms. Therefore, this is just 3x squared minus 2. Once again, for this problem, for both steps, at no place did we have a fraction with a variable on the bottom, nor did we have an even root radical. So there were no excluded values. Inverse functions. Two functions, f and g, are inverse functions if, spelling error here, that is embarrassing. If f of g of x equals g of f of x, which in turn equals x. This is not a misprint. IFF means if and only if. What that means, if you go back to your geometry class, it means a statement is true and its converse is true as well. What does that mean? Let me give you an example. If you breathe Have I spelled breathe right? Don't know. Then you walk. I'm not saying that's true. That's just a statement. The converse would be, if you walk, then you breathe. Since this says if and only if, it means this would be true no matter which order you would say it. So we could take this inverse functions definition and we could read it in one of two ways, and they would both be true. We could say, if two functions f and g are inverses, then f of g of x equals g of f of x equals x. We could also say it this way, and it would also be true. If f of g of x equals g of f of x, which equals x, then the two functions are inverses. You can read it in either way, and it's true, forwards or backwards. So example C, determine if the given functions are inverses of each other. Well, we do this composition, and if we get the answer for x for both of them, then they're inverses. If we don't get the answer of x for both of them, then they're not. So f of g of x equals f of x plus 7 over 4. Function f is 4 times x, which we're now saying is x plus 7 over 4 minus 7. This fraction, x plus 7 divided by 4, we are multiplying it by 4. In essence, we are taking x plus 7, multiplying it by 4, and dividing it by 4. Since the x plus 7 is being acted upon two things, 4 and 4, with opposite operations, multiplication and division, those 4's cancel. In essence, we're saying 4 divided by 4 is 1. 1 times x plus 7 is x plus 7. Bring down the subtract 7. 7 minus 7 cancels, and you get x. With addition, when I say cancel, it means you're getting 0 for an answer. So are these functions inverses? Don't know yet. We have to make sure that g of f of x also equals x. F of x is 4x minus 7. So I'm putting 4x minus 7 in place of my x's into function g. Here's something you cannot do. Some people say multiplying by 4, dividing by 4, they cancel. They don't. The reason is the 4 in the numerator is not being multiplied by the entire numerator. If this 4 was out here and this was like this, then you could cancel those 4's because the 4 is being multiplied by everything. If it's not being multiplied by everything, you cannot cancel it. So what can we do? Well, we have a minus. I think I wrote this down wrong. This should be a plus. We have a minus 7 and a plus 7. That gives us 0. Then we have 4x over 4. Now we can cancel those 4's because we're multiplying the entire top and bottom by 4, so we get x. We get x for both answers. Are these inverses? Yes, because once again, this says up here the definition. If you do the composition, you will get x for both answers. Number 2 seems to be more simple, which in essence makes it more complicated. F of g of x. It's f of x plus 7. I'm replacing g of x with x plus 7. So I'm going to go to function f, which is x minus 7, and in here I'm going to put the x plus 7. My 7's cancel, so I get f of g of x equals x. So this has the potential to be inverses. G of f of x. That's g of x minus 7, which is x minus 7 plus 7, your x's cancel. We get x for both answers, so they're inverses. Example D. Properties of inverse functions. This is not a definition, this is a property. Something that's true about it. It doesn't define it, it's true about it. It's like if someone wears glasses. That's a fact about that person. It doesn't define them. It's not, hey, that's the kid who wears glasses. No, that's someone that I know who's a great person who happens to wear glasses. Property of inverse functions. Suppose f and f to the negative 1, this right here, it is written as an exponent. But that's not what it is. I mean, it's a superscript, it's written high, it's small, but it doesn't mean an exponent of negative 1. It's typically read f inverse. That's the notation that we use in math to denote an inverse of something. Suppose f and f inverse are inverse functions. Then f of x equals y if and only if f inverse of y equals x. I'll explain how to put that into practice here in example D, because that's a little confusing. Example D, find the inverse of each function. Then decide whether the inverse is a function by circling yes or no. I have steps here on how to do this problem. To find the inverse, substitute y for f of x. Replace f of x with y. That's the first step. Step 2. Then exchange all x's and y's. That means take any y's you have and make them x's. Take any x's you have and make them y's. This is not a great y. It looks kind of like an x. Let me make that clear. So I made x's, y's, and y's, x's. 3. Solve the equation for y. Solve means get y by itself. Let's divide both sides by 4. I'm going to do so. I'm going to write it like this. 1 times x divided by 4 is 1/4 x. 4 divided by 4 is 1. Then substitute f inverse of x for y. That is the inverse. One-fourth x minus 1. Is that a function? Well, hopefully you know what this looks like. This is in slope-intercept form. Has a y-intercept of negative 1. Has a slope of 1/4. So essentially it looks something like this. It's a line. Any non-vertical line is always going to be a function. It passes the vertical line test. If you run a vertical line over this, it will only touch the graph in one place at a time. So yes, it's a function. Number 2, same thing as number 1. Replace f of x with y. Interchange x and y. Get y by itself. Opposite of cubing is cube rooting. This is an odd root. You do not do plus or minus. Replace y with f inverse. Is this a function? If you were to put a number in for x, would you get one answer, or could you get multiple answers? You're always going to get one answer. This is going to become more clear to you as we progress. This is a function. At this point, if you're not sure, take this and put it into your calculator. You'll find that it looks like this. Something like that. It's not a great picture. This also passes the vertical line test. This is what that function looks like. Won't be long and you'll know by looking at that. I know what that looks like as a function. Alright, number 3. This is our last problem. Was to find the inverse. Replace f of x with y. Interchange my x's and y's. Get y by itself. I'm going to add 2 to both sides. Square root both sides. When you do an even root, always do plus or minus. And then I'm not going to write f to the negative 1 of x again because it's written down here. You need to write it someplace, but it's already written. Is this a function? There's 2 reasons why it's not a function. One reason is using the logic of, hey, if I put a number in, how many answers do I get out? Put any number in here for x, except for negative 2. Any other number in, you're always going to get 2 answers. If I put a 7 in, 7 plus 2 is 9. The square root of 9 is plus 3, and it's negative 3. That's 2 answers. If you get more than one answer, it's not a function. Also, which you're going to learn this later, this graph looks like this. Does not pass the vertical line test. Or in a vertical line, it's going to hit this at more than one location. Therefore, it's not a function. Thank you for your time.